why don't we get started?
Okay.
In our continued webinar series, primarily for Amrita AHEAD students and soon-to-be students, we introduce people that can add knowledge that will help you not just now, but when you try to get better jobs in the future. You can understand a little bit more about what is easiest to think about as growing very fast, and some of those easiest to think about areas are technologies that are becoming more and more important in our lives. Probably artificial intelligence or AI has been around for some time as a field, but most recently, because of many other factors, has become an add-on to many industries today, and maybe much more of an add-on in the future. So in order for you to understand this, you can read a big book, or you can go see 10 different webinars. But I have asked Mr. Sarthak Behura to come and give you a synopsis about where it has come from, where is it going, and what does it need, and allowing you to also ask questions that relate to your situation. So Mr. Behura is someone that graduated from Amrita University, okay, and has done extremely well. He has joined one of the premier companies in artificial intelligence that is working on supplementing our minds in doing investments. But he also knows many other areas along with it. So this presentation, where you'll be discussing the entire AI field, is more from an overall artificial intelligence industry perspective. And with that, I'd like to turn it over to him to begin.
Well, thank you, Jaisha. It's always kind to hear from you. So let me just quickly put this on the share. Guys, let me know if this layout works. Yes? Does this work?
It's quite good. It's quite good. You might want to make it full screen. And I ask everyone else to stay on mute with no video to save bandwidth.
So if I go on full screen, I have a dual screen setup, so it actually takes it to the other screen. So you'll have to.
Okay. Then as you like.
So guys, thank you for actually taking out time on a Saturday afternoon after Dashara. I know these are the times where you would want to rest, but if you've spent an afternoon talking about a technology that, at least in my mind, it's fairly transformational, I think you would have achieved something. If you go by the title of the talk today, can AI help you become richer? Well, you can become richer many different ways. You can invest in, companies that are doing mainstream artificial intelligence. You can work as a professional and make a lot of money, being an AI expert. I mean, that's probably the shortest route today. But in a sense, although this will not focus on investment ideas per se, for that you'll have to download the app that I've designed. It's going to be more on how the industry is evolving and how it has changed, how it has transformed, and what is the way forward. Yeah. So let me go to the second slide that I put together for this talk. This is one of the very fundamental questions that I ask when I hire a ML engineer or, a professional in data science. What is the difference between the three things? What is the difference between a deep learning algorithm, a machine learning algorithm, and an artificial intelligence? So the thing is, if you ask 10 people this question, they will answer, in a very interchangeable way, right? It's because a lot of working professionals have a very good operational knowledge, but when it comes to research, etc., well, I think from an Indian's context, we're still some away. First, direction. We need direction, and we need some more investments in that space. But just to give you some context, how these three things are different. Let's start with deep learning, and this is where all the action is. Problems that never used to be solved by statistical or probabilistic models, started getting solved by deep learning. And I'll start getting into details as I further progress on my talk. But the idea for deep learning is, having multiple layers, hidden layers, and probably we'll talk about that a little bit more. Machine learning encompasses both deep learning and statistical methods. It's essentially a way where, you don't have to write 1,000 lines of code to teach a machine something, right? It is through observation and back propagation you arrive at those conditions, or rules or hyperparameters for the technical folks. Yeah. And what is artificial intelligence? Well, machine learning, deep learning, you're giving data for the system to learn. It's essentially learning from what it has seen. An AI system is much more broader, to put it safely. It does not necessarily have to have seen the problem to solve it. That's the first thing, right? And again, how do I define that? Well, that's the problem, right? The human intelligence is very broad. We work in multiple, we multitask multiple things. We walk, we speak, we do this, etc. But it's the same thing a system. Well, there are motor skills, etc., that are available that systems are leveraging on, but it's still far away from where you would say that artificial intelligence exists in its full form. So, like I said, machine learning is a part of AI. Deep learning is a part of machine learning, right? And again, as we evolve in the knowledge curve, we will discover more and more breakouts and quadrants and cohorts that do different things, right? If we go to the next slide, it's very important to understand, like Jay sir rightly pointed out, it's been there for some time, in 70s. Even if you really look, the earliest indication of a machine learning algorithm was in breaking the German Enigma machine, where the Hail Hitler phrase was captured, and it was the key for the entire Enigma machine, right? So those were the first instances of machine learning. But although the machine then couldn't learn as much compared to what you can do in a phone today, but that's completely different. But it's been there. The idea of actually designing systems, etc., it's been there forever. And the Enigma machine was again a narrow AI designed to break the code, right? The same ways, anything you see today, from chess, facial recognition, virtual assistants, these are all narrow AI. They solve a single use case. And in all of these cases, like facial recognition, etc., these are classification use cases where a system learns about your face, how the different features look like, and it tries to match it in terms of deep learning or a CNN based model. Yeah. So the idea for narrow, like I said, is prevalent since a long time. All these are narrow AI concepts. In the graph, or rather in the infographic below, you have all of these use cases that focus on just narrow AI, right? Because they train for those use cases. Mobility also, how cars operate, do they stop, don't, all of that associated features, learning set, is a part of one use case or one problem. That's why they're narrow. And there's also a picture of, I don't know, a Terminator or something that broadly can do all of this. There have been some examples of such, sentinel beings or whatever you call it. There was one, it got mainstream attention some days back. But then again, it's a lot of, what do I call it? Supervised learning packaged together. It's not that it can make decisions of its own. It's just that a lot of narrow use cases are combined. So it feels like a, broader AI, right? So that's where we are at. We are making a lot of innovation in this space, particularly in speech recognition, computer vision. These are the hottest areas of narrow AI because, they can work in isolation. Like we take computer vision, right? For self-driving cars, automated driving assistance, etc. They just focus on one, computer vision, and as the technology progresses, you would have self-driving cars. For a broader AI to evolve, all these modules from vision, speech, adaptability, and reinforcement learning, all of these bits have to develop. It cannot be progress in one area that can lead to creation of a broad AI. But as we know, the resources are limited in this world, and everybody is chasing their use case in that field. So the the development is disproportionate. For example, there's a lot less work being done on auditability in terms of understanding the decision making and how the hyperparameters affect results. But a lot's being done on mobility, right? For example, motor skills, all those used robots that you see on social media. So again, it gets driven by use cases industry is working on. So it's not always harmless. So to go a little deeper, this is essentially a differentiation of what a narrow AI versus a general purpose AI is. Like I mentioned, general purpose AI can solve unfamiliar problems. Obviously, it's not a reality yet. So whatever you see is just narrow AIs put together to resemble a general AI. Again, it's very similar to human intelligence is being said right now, but to what degree it would be correct, again, is a matter of conjecture, because we can only think of structures that we have been conditioned with. Maybe, with quantum computing coming in and computing powers, solving hard NP for the software folks here, this might not be required at all. They can surpass human intelligence in the way humans think. I'm sorry. Right. So all these examples of narrow AI, Watson, Google Assistant, AlphaGo, they've been trained on one use case and millions of iterations of that same data set. So that's why they're narrow. They cannot solve. You cannot, like for example, you cannot take an AlphaGo bot and put him in front of a chessboard. It just cannot work, right? Because it's been optimized and trained to do one task. Now, if I go follow down, I have a flow chart in terms of how the sequencing of events, in terms of how the AI roadmap has evolved. Again, as you can see, it's on 1642 from the mechanical calculator, made a lot of progress. But as you can see, from 1955 to 1980 and from 80 to 1997, that's what we call the period of nuclear winter in terms of the AI space, because the neural networks came in this period, 80s, right? But that's the thing, computing power wasn't powerful enough to have deeper networks, deeper layers that a human can, for example. And that's why with single cores P1 machines, you could never design those systems. But right now, if you look at a RTX 3090, that's like close to 20,000 crores, I suppose. GPU cores. Typically, we use GPU to train a lot of algorithms. GPU cores are more effective when it comes to repetitive tasks versus processors, because processors have what do you call a complex set in terms of instruction set that doesn't really do well in the math. So computing power has, my point is computing power has gone exponentially high, and that's one reason for the shortage, because the same graphics cards are being used for mining, the same are being used in research labs everywhere. And look, we are also, kind of hoard GPUs when we get our hands on it, because the kind of data that we are starting to see, it requires a lot of processing power. Just to iterate on this slide a little bit more, 82, this period, nuclear winter, what you can see here is there's this guy called Ian Goodfellow, who comes up with the GANs, which is your deep fakes and all that. This is the time that evolved, right? And now it is getting, algos take 4-5 years to mature typically, with papers and all of that. Actually, in 2014 to 2018, that period, saw stupendous growth. A lot of those in Facebook Labs and Microsoft Labs, etc. But now, if you really look, the same algorithms that these guys used to work on, like for example, CNNs and 100-layer models, they're available. You can plug and play using TensorFlow. TensorFlow, if you guys are unfamiliar, is a Python library that you can call on all these models that are pre-configured. And typically, if you're looking at classification problems, a lot of it can be transfer learned, as in the same model architecture that worked for that problem can be fairly exported for your problems as well. So all that has created an environment of enablement, a ecosystem of, you know, collaboration, for lack of a better word. The last time I checked, there are some 40,000 Python libraries that you can download and you can use for free, right? So that has helped quite a bit. You also see some examples of Roombas and the vacuum cleaners that, look, everybody bought them during the lockdown. There's no maid and Ender. These guys sold out very quickly. So that's one mainstream application of, autonomous cleaning bots, right? So it's already there. So uh, if you go further, this is a very important slide because it broadly talks about how different verticals are in the industry. As you can see, the first column, it's called cognitive modes, right? So pattern recognition, computer vision, these are methodologies. Rule-based RPA is the next column. Essentially, what a lot of IT companies, bread and butter, right? They made this for 20 years. That used to be the main driving factor for in Indian IT. So where, they would create systems that could, replace human beings or, make them more powerful, use hybrid solution architectures. So all of that rule-based RPA, we are beyond that. A lot of it is now in diseconomies of scale, to be honest. I mean, leave out emerging markets, but developed markets, it's, done to death. Now that 17 to 2025, if I speak to you about a few numbers, um, close to 8 to 10 billion is being spent on computer vision based problems because it has use cases relevance with automotive manufacturers and so on. We do a lot of that, by the way, in computer vision in investments and asset management and advisory space. Um, um, the second biggest industry in that narrow AI space is algorithmic trading. That's close to around 7.5 billion. This is speaking from Statista numbers. Now, if we go further from supervised learning, you would have a lot of value-added features, for lack of a better word. Recommendations based on profile of one, styles. Previously it used to be like people like you used to be grouped in a segment based on your behavior, and that used to drive use cases or recommendations, right? But now the technology has evolved so much that you can create a user of one, and based on every action that you take, it can be hyper personalized. And again, that's not going macro but micro in terms of how the recommendations are served. And then you have unsupervised systems, and then self-aware unsupervised learning. I really like to speak about them because, again, it's in the realms of conjecture, right? Because we only see what we've been conditioned to see, right? But sometimes it's not necessarily true. I mean, the way technology is evolving, right? Those two things could be very, very different from what we can imagine. But the closest you can see for those two are self-driving cars, where not the level 2, that Mahindra is selling right now. It's typically level 4, where, you don't have a, handle, or you don't have a riding wheel. So besides that, there are a lot of intelligent systems being built in that unsupervised space where reinforcement learning based bots based on market activity, they're not coded, they just identify the patterns and they just work directly. But that's, again, like I said, 2025 and beyond. So now if I go to the next slide, I wanted to speak to you guys about, how a typical ML model is built. Because if you're going to be a professional, there's a 90% chance you'll have to follow the same cycle. And again, this is not just me, this is how the industry does it. The very first thing, um, in any machine learning project is to understand its discovery. What kind of data do you have? It's temporal data. Does it have a lot of missingness? That entire discovery for project discovery is where you identify the use cases. Okay, you want to increase efficiency of advisor by 30%, or do you want to improve expense ratio to a certain number, or predictions like which are the customers that you can predict that you're going to leave, but you want to hold on to them. So all that is handled in the discovery phase. Data discovery is, again, like I said, temporal data, how many data columns you have, what is the nature, what is the data dictionary that covers all the fields. That's the stuff that we do here. Feasibility study is it on the cloud? Can we deploy it? What is the run times and stuff like that? Is it compliant? Because take for example, if you're doing it for loan processing, is it fair to different skin people? So all of that has to be taken into account. Then obviously you have model selections, data wrangling and labeling. This is where you start with the machine learning stuff. So let's say you're doing a classification problem and you have 3 class of interest. So you identify, you look at the density, if there are enough samples, all that bit being covered there. Ingestion and pre-processing is, you have to normalize from, 0 to 1 or, 0 to 100 percentile in most cases. And typically when you're looking at financial data, etc., it makes a lot of sense because you'll have numbers that are outliers, right? Then you get to a feature engineering. I'm sorry, I'm scrolling through this rather quickly because probably this requires a couple of hours in itself. Feature engineering, yeah. So you combine 2-3 features and you look at predictability power of that feature against the variable you're training for. So that's something that, that's typically 30-40% of the work in any ML project. What is the input that you create and how do you engineer them? Then the model training start, which can run from seconds to days, depending on the magnitude of data, again, and the layers and the complexity of the model you're trying to build. And a lot of people actually in India are not model trainers. I mean, a lot of people get stuck in feature engineering, etc. Model training and innovation. If I look at the entire data science population of this country, it would be around 10% who do that and do that well. So model evaluation and validation is how you do in your blind test in periods where the data hasn't been seen by the system. And again, you have, for example, if you're looking at investment data, how you're doing in bull market, bear market, what's your beta like? So you have to make sure, because you really don't want to end up with a high beta strategy. Then there is inference, visualization, deployment, post-processing. These are, again, different based on, if you're doing it on an app, you're delivering it through an API. Again, a lot of your production depends on how you package it. So I'll give you some examples later on my talk, where I'll show you different examples of how we can package the same intelligence. So I wanted to give you some examples. I know I'm spent 25 minutes. I have a little more time to go, so I'll quickly run through this. I wanted to give you examples from the investment industry. 2 reasons. So I've been working on it for a long time. And the second thing is, I think this is where the biggest investments are being made. Before we start, I wanted to speak to you about how the do-it-yourself investors are transforming. Let me decide. So obviously everybody doesn't want robo-advisor or a mutual fund or an ETF. They want, typically the millennial population, what we have seen is they want to be in charge of their finances. Then I'll not go through all the 8, but I'll point out the ones that I find very, very, game changing. No barriers. Look, sitting in India now, I can invest in 120 exchanges. I just have to use my LRS allowance. In an hour, I can do that globally. So a lot of this broking services are getting commoditized, right? Because you cannot charge a very high premium brokerage anymore because everybody is giving you the same service. Um, what people want is they don't want a research paper to read when they're making an investment decision. They want something that works, something they can understand. It's like swiping right. And again, cost. People are willing to pay micro ticket size than an expense ratio based model. Again, that it's slightly biased from the Indian markets, but I think globally also people want to pay at the time of purchase rather than pay for a monthly commitment or so on. So if you go to the next slide, where this is where I'm discussing about Bridgeweave. What do we do and why do we do it? Look, I've spent 15, 20 years different times with UBS, different AI startups. We always felt that the best of technology that we used to create, again, used to be used for ultra high net worth desks and, um, um, people who could afford it. And one of the biggest motivations to create Bridgeview was to take this game changing technology and make it available for the retail investors, people like us who do not want to pay a big ticket purchase to a JP Morgan for research or invest in a portfolio the minimum where it's $5 million. So the entire idea is to create something that's accessible by retail investors. So what do? Essentially we design algorithms to predict markets, predict asset class moves, strategies, uh, technicals, all of that insights that we predict. The biggest bit about us is we use only machine learning. So what it does is it automatically makes us uncorrelated, and that's a very strong word, uncorrelated from what's happening in the market. So a lot of money managers, a lot of traders like us because, in an industry that's full with people, spreading information, etc. Here's an approach that's completely generated by machines, and we've done well, to be honest. So how do we do it? So like I discussed, the feature engineering, the process of integrating all the features and making a prediction. We do that for every single market. We cover close to 21 markets right now. And for every market, we make predictions and sector neutral predictions. So we don't go long on one sector. We identify the winners from each sector, looking at how the images look like. And all these images essentially are pixels, right? Combined together. And each of this pixel is a grayscale image at the end of the day, right? It's red RGB, right? And that RGB value is essentially a feature point. It could be price earnings, it could be price to book, it could be for finance professionals here. That's what we do. So all that pixels is essentially financial data transposed into grayscale images. That's a trade secret. Now, if I go to the next slide, I'm talking about, I'm sorry, Jess, I know I had to stop at 3:30. I'll just take a couple of minutes more. So I'm talking about.
No, actually, you have, we started at 3:00, so 3:05, so you got until 3:40 or so. That's okay.
All right. Thank you, sir. So I just wanted to speak about the current ecosystem. So, if you want to service the market with game-changing technology, you cannot have one size fits all. You have to package them differently. So as you can see, the retail app is at the middle of everything, and for us, and you'll have API training for people who are do-it-yourself, who want to create their own bots using our intelligence. They can do that through the API marketplace. So, all you have to do is a couple of API queries to find out which stocks you're long on, short on, stuff like that. Enterprise version, well, it's the hedge fund world. They want the most liquid securities, 200 securities, and they really want to go short on a lot of these things. And they want price targets, stop losses, a lot of those good to have stuff that retail investors do not get it. And one of the most interesting observations I've had different between retail and enterprises, retail are not looking for astronomical returns. They want a balanced algorithm. 70-75% win rate with an 2% alpha over the market is fine for them as long as the drawdown is not high. But for the enterprise, the hedge fund world, it's quite the opposite.
Yeah, actually, Sarthak, can I make a suggestion to you?
Yep.
I think a lot of people may not know the basic lingo that you're describing.
Okay.
So it might be good to kind of keep it at a basic level and let the people that know ask you the special questions.
Sure.
Because, I know that obviously you and I know this, but I think many of the students are BCA students, in other fields that may just want to focus on the AI part of it.
Understood, sir. No, I'll just overall broadly touch them. So enterprises, when we sell to wealth managers and hedge funds, so their ask is broadly different from what a retail investor wants. And the information they want is different. Trading bots is people who don't want to trade. They find it gut-wrenching to sit in front of the terminal, one click, and the bot does it for you. It sells, buys, does everything. FTM is follow the machine. So the idea is you don't do anything, you just press a button, and every time you make changes in our investment portfolio, it changes. Invest AI crypto is your like it suggested, Bitcoin, Ether, long short signals on them. So, but the entire essence of this is once you have the enabling technology, all of these are predictive algorithms packaged differently with different KPIs, right? And that's how you're servicing the entire market. Now, if I go to the near future, this was the slide I wanted to speak to you about in terms of expected growth of artificial intelligence. Cybersecurity used to be one of the biggest things, but quite honestly, when the industry realized that using AI they can boost revenue rather than have cost controls and compliance, most of it is going to image classification, tagging, all of that. But then it is algorithmic trading. We as a company are present in top two quadrants here. Patient data, scalable. This is again picked up heavily after COVID. There are exclusive startups which have a rich set of data sets. Hospitals are monetizing that data and they're making a lot, and they're getting the first right where they can use whatever they find in their hospital first right. So a lot of these things are coming into the equation. Now, if I further go into the end, I just have a couple of quotes. So this is from Harvard. There was a recent article, they called this is the sexiest job of the 21st century. I kind of agree, not because of the glamour and everything and all that, but this is the job or the task force or the people who will transform the next 100 years of our lives, right? It's how they shape the architecture, what is AI ethics, responsible AI, and all of that. So it's not sexy, but it comes with a lot of responsibility also, because we know rogue AI can be really, really dangerous. And that's why I wanted to stop my talk so that I have some time to take questions. Hello?
Okay, we have quite a few people in the audience. Is there any question for Sarthak on what he has been talking about, or anything that you're curious in for the AI field? Anyone? You can just, we don't have enough people to make it on a call basis or a polling basis. So if you have something, please ask it. Maybe I can just start, the conversation by asking you a question.
Sure.
If you take a look at an ML engineer or, the categories, pressure, okay? Can you give an idea of what the people that were to be hired by you or one of the comparable companies, what is their salary that they have to get? What is their annual pay? And what is the general responsibility that they have?
Right. So it's very Interesting question. See, typically when we hire ML engineers, it depends on the kind of backend technology that we use. Typically, most of them use Python. And when you're getting in as a Python engineer, you're typically starting off at around 7 lakhs, 6.5, 7 lakhs. Unless you're from the IITs, then you would command a slight premium, maybe 10, 11. But that's the thing. Year one and year two of your job, it can immediately go up to 15, 16, and even 20 lakhs. That's because once you understand how Python works, see, the syntax doesn't change, right? It's how you upgrade your knowledge to become a data scientist. And we prefer to do that. We generally like to hire freshers with some interest in machine learning and try to train them, because it's very hard to find proper people who can work on the same kind of engineering stack that you've created, because it's not like off the shelf available anywhere. So all the features and everything that we create is proprietary for us. So we generally have to train them. And and to answer your question, 7 lakhs as fresher, in 2 years it can go up to around 20 lakhs. And if you're after 4 years, you're transferred into a good data scientist, it could be in excess of 45, 50 lakhs.
Are there, some ways to demonstrate knowledge of Python that you would say and take a look and say this person's a very good candidate? What would they have to do as a project or as work?
See, everybody nowadays, it's not a very difficult language to learn, and most people can learn it. Sit in front of a Udemy upgrad course, you can still learn the operational side of it very quickly in like weeks. But what we typically look in a candidate is look at his GitHub, what kind of algorithms he's been sharing, what is its activity in terms of code, in terms of papers he's written, and all of that bit. Because what we find in India is a lot of people have operational knowledge, as in they can deploy an algorithm, they can write the code, but very few people can actually understand what's going on behind the code, in the sense that how does the system work and all of it. Those are very, very hard to find, because a lot of this ed tech companies that you see, essentially YouTube driven, or videos driven, they show you how to write code, and the theory sessions and digging deep, it's not there as much relatively. And that's one of the gaps that we see considerably. But in terms of demonstration, yeah, please work on your GitHub page. LinkedIn also we look at extensively in terms of if somebody has a firm, what kind of problems you've worked on. Those things are important for us. Yes. All right. Any more questions?
Hello.
Anyone else with any questions, or should we call it a day?
May I know what software is most preferred for machine learning?
See, I mean, it's the language that makes a difference, because software wise, you can use anything from your PyCharms to, there are many, Node.js IDEA, IntelliJ IDEA, Jupyter Notebook. But what we see a lot is a lot of freshers use Jupyter a lot, because they're more familiar with IPython notebook kind of a structure, where every cell you have to enter a code, and if that works, you go to the next one. But again, it comes with a lot of drawbacks. My advice is don't go by technology. So don't go by the software. Everybody offers you the same thing. It's your understanding that's more important. You can port from one software to the other. It will not, as long as you know the language, it wouldn't take more than half a day max.
Thanks.
All right.
Okay, I'm going to assume that any other questions will come some other time. Any other questions, or should we, thank Mr. Berger? Okay, so Sarthak ji, it's been I just want to thank you, because what you do, even though I think many people could listen to it, they may not know the importance of it because of lack of exposure to the world. And when you hear something like this, there may be an automatic barrier saying, my God, it's only for other people, it's not for me. And I think that what you have done is explain things in a very, very, very straightforward way to let people know that it is possible, but obviously with some people that don't have a non-technical background, then it's difficult. But even with a non-technical background, you can work with the engineers that are doing this to do the normal things, marketing, production of the product, etc. So all that I think was covered, and I would just thank you for that. And the next thing is for the investment business. The reason I interrupted you is because the things you're saying are all industry practice kind, such as you may think that if you have some savings and you want to grow it, that you take it to this investment person and they do all types of fancy, analysis. But the reality is what he said. Most people don't do those things. They don't do it properly. They do other things that are improper. And by having Sarthak ji talk about AI as a way of supplementing it, and he just small mention, he said, we do very well. That tells you something. So I would urge you to take a look at his entirety of his talk and try to learn more in this area, because it's not just for technical people, it is for business people, but you have to step back and say, I have to know something before I become a business person, and not just say I don't know much. Okay?